plus 9 is equal to 7 plus 9 is 16. Okay. All right. Step 4 here. You're going to factor the thing from step 3 into a perfect square. And I'm going to show you how to do that. I've got like a little hint here. So you're going to factor the equation. Equation has an E. From step 3, right? Into a perfect square trinomial or a perfect square. Perfect also has an R. Okay. Now, the perfect square, and you're like, well, how do I know what the perfect square is? This is where my little hint is. The perfect square is x plus whatever b divided by 2 was. And then the whole thing is squared equals whatever the number is. Okay? So in this particular case, if you look up there at my orange area, b divided by 2, 6 divided by 2 was 3. So 6 divided by 2 is 3, so it's x plus 3 squared equals the number we have, which is 16. Okay? So that's how you get your perfect square equation there.
Could you scroll slightly up so I can see some of the stuff you wrote just slightly above? Thanks.
Mhm. Okay. And then what we did on, what is today? Today's Monday. No, today's Tuesday. So last Thursday. Okay. Then we're just going to solve it. I know it goes 1, 2, 5, but follow the numbers. All right. Now you're going to solve for x. Okay. But since this is a square root equation, right? You've got x plus 3 squared is equal to 16. Remember, when you square root that, you end up with 2 equations. You're going to end up with 2 equations and 2 answers. So you've got x plus 3 is equal to plus or minus 4. And then you get your x plus 3 is equal to 4. And then x plus 3 is equal to negative 4. Okay? Subtract the 3, x is equal to 1. Subtract the 3, x is equal to negative 7. So there are your answers, 1 and negative 7. What questions do you have on this one?
I have a question. So, suppose during the exam, there is like a question that like this that you have to make the perfect square. Will it be written that we have to make a perfect square or just written that factor?
Um, well, you will have to make, if it tells you to solve the problem by completing the square, you will be expected to follow these 5 steps. You
Oh,
don't
so
have
it
to
will be written.
say what? I'm sorry, one more time.
So it will be written, right? That we have to find the perfect square.
It will be written that you need to solve the problem by completing the square.
Okay.
So the one on the quiz that you're taking on Thursday that has this completing the square on it, you will have to solve it using these steps And using any other steps, you will only get like, I think it's like 1, maybe 2 points on the problem if you use something else. Because it's just, unfortunately, it's just they want you to use this particular method. Now, that there's only a couple instances where you are told 100% that you have to use a specific method. And that doesn't happen very often. It only happens a handful of times, and completing the square is one of them. Okay. All right. Number 2, same thing. Okay. So first things first, subtract the 1. So I've got y squared minus 4y is equal to -1, right? So that was the first step. Okay. The second step is to use my formula, b divided by 2 squared. In this case, it's -4 divided by 2 squared, which is -2 squared. And -2 times -2 is +4. Add the 4 to both sides. So y squared minus 4y plus 4 is equal to -1 plus 4. So y squared minus 4y plus 4 is equal to 3. Okay. Make your perfect square. And remember, the perfect square in this case is going to be the b divided by 2. And in this case was -2. So it's going to be y minus 2 squared is equal to 3. And it's not really solving for x, but it's pretty darn close. It's a little neighboring letter. We're going to solve for y here. And this one does not come out to be nice, lovely numbers like problem number 1 did. Okay, take the square root, you get y minus 2 is equal to plus or minus 3. Sorry, the square root of 3. Let me just throw that square root in the garbage. Just kidding. Don't do that. Square root of 3. Then you're going to add 2. And in this case, when you have a irrational answer, you can actually just leave it together. You don't have to separate it. Whereas with this first one, I had the perfect square root of 16 was the actual number 4, and then I separated it into 2 problems and did it that way. When you have, and these are called rational roots. When you have irrational roots, like with the radical and so on, you do not have to separate them. So this particular one, your answer, you can just leave as 2 plus or minus the square root of 3. Okay. Do not give me decimal answers. Leave them as exact answers. Um, exact answers are things you do not have to round.
I have a question.
Yes.
On the quiz, can we have like little notes telling us, like, reminding us just of like the little formulas, like,
No.
okay.
You will have a formula sheet on the midterm and the final exam, but you cannot have formula sheets on the quizzes. Okay. Questions on the purple one? Okay. All right. If you look here at this third one, instead of just being x squared, it's 3x squared. Now, instead of calling this step 1, we're going to call it step 0, right? So step 0 here is I have to make the x squared equal to 1. So, right, whereas with the purple, we started at step 1. With the multicolored intro, we started with step 1. Well, we need step 0 in here, okay? Step 0, we are going to have to divide the equation by A when it does not equal 1. So this doesn't happen very often, but it does happen. So in this case, I need to divide by 3. So I have 3x squared plus 12x plus 5 is equal to 0. And I have to divide everything by 3 because A is 3. So I'm left with x squared plus 4x plus 5 over 3 is equal to 0. Okay? All right. Then we can start on step 1. I'm going to move the 5 over 3 to the right. Whoa, I put a 3. It's be x squared plus 4x is equal to negative 5 over 3. Again, guys, we have calculators to be able to add, subtract, all those fun things with fractions. So don't be intimidated by fractions because you have a calculator that can do all the work for you. Okay? Then we're going to do our b over 2 squared, b divided by 2 squared, which is 4 divided by 2 squared. And 4 divided by 2 is 2. We're going to square that, and 2 squared is 4. Okay. Then we're going to add 4 to both sides. So I've got x squared plus 12x. I'm sorry, plus 4x. I started mixing my stuff. I apologize. Plus 4x plus 4 is equal to negative 5 over 3 plus 4. And you do want to keep this as an improper fraction, not a decimal, nothing like that. So you end up with x squared plus 4x plus 4 is equal to 7 over 3. You do want to keep that improper fraction there. Okay. 4, we're going to change that into a perfect square. So again, that's the b divided by 2, which in this case is 2. So x plus 2 squared is equal to 7 over 3. In step 5, you're going to solve it. X plus 2 squared is equal to 7 over 3. And again, this is going to be an irrational answer because there is no square root of 7 over 3 that doesn't result in a bunch of crazy decimals. So x plus 2 is equal to plus or minus the square root of 7 over 3. Subtract 2, so x is equal to negative 2 plus or minus the square root of 7 over 3. If you want to rationalize your denominator and do all that fun stuff, you certainly may do so, but it is not required for me. So you can just stop here. Now, if you put the square root of 7 over 3 in your calculator and it simplifies it for you, then that's fine. That's perfectly fine. You don't have to be like, but my calculator simplified it. That's fine. I don't care. The little green calculators that I told you to buy will simplify square roots for you.
Um, I have one question. It's like,
Yep.
so just after, like in between step 0 and 1, I, I was just curious. So what happened to the coefficient of of 3x squared in the,
I divided everything by 3 because that's what step 0 told me to do.
okay,
Divide the equation by the a when it does not equal 1 and 3 is not 1.
okay, okay, that makes sense.
Okay. I want you guys to do the last one. Do that one. Would anyone like more time?
Just one more minute for me.
Yeah, no worries. Leah, one is right. And Apsana, yes. I'm sorry. Leah, the 6 is right. It's the other one that's not. Yes, ma'am. You got it. Subtract the 12. Divide the b by 2. Okay, there you go. Add the 16 to both sides. Z squared minus 8z. Oh my goodness, I've got the plus. Plus 16 is equal to negative 12 plus 16. So z squared minus 8z plus 16 is equal to 4. Do your perfect square. In this case, it's z minus 4 squared is equal to 4. And solve. You have z minus 4 squared, z minus 4 is equal to plus or minus 2. So then you got two problems. Z minus 4 is equal to 2, and z minus 4 is equal to negative 2. So z is equal to 6, and z is equal to 2. So you got 6 and 2. Questions on that problem?
Could you just scroll slightly up? I'm like screenshotting these so I can like practice them later. Oh, I don't know if you can get the whole thing in.
I'm working on it. You want to give me a second there, champ?
Thank you.
You're welcome. I can only go so fast. I don't got a mouse. I have to use the stupid touchpad. Anybody else? All right. Interestingly enough, we only do a little bit with the quadratic formula, so I'm just going to kind of hit some highlights here. I'm just going to do these first two. Just because we tend to focus more on factoring than the quadratic formula, and we tend to give problems that are factorable. Okay, so obviously the quadratic formula is a tool that you should keep in your little tool belt, in your little brain pocket there, but it is definitely not anything we really focus a terribly lot on. Okay. So, unlike completing the square, all of your stuff must be equal to 0 first, okay? So if you're using the quadratic formula, your equation must be equal to 0 before you begin, okay? So if you use the quadratic formula, your equation, oh my goodness, typing is hard. must be equal to 0 before you can begin. Okay? So that's my caveat there. That's my only statement with the quadratic formula. It does not matter if A is 1, 2, 3, 1,000,000, where it did with completing the square. The quadratic formula is it has to be equal to 0. So in the case of this first problem, I do need to add 10. So the problem I'm going to be working with is x squared minus 7x plus 10 is equal to 0. Okay? So where we have A's, B's, and C's in the quadratic formula, those are only the numbers, right? So there should be no x's. So in this case, x is equal to the opposite of b. So it says negative b, but you'll see here that b is already negative. So it's going to be minus a minus 7. And then plus or minus the square root. And the biggest mistake that folks make on this quadratic formula is they don't use parentheses. If you don't use parentheses for negative 7 squared, you are going to get the wrong answer. Because negative 7 squared is positive 49, but if you just put negative 7 squared without parentheses in your calculator, it's going to tell you it's negative 49. And there's a whole mathematical reason and everything behind that that I'm just not getting into today. And if you'd like to hear about it, you can set up a time to talk. But anyway, A is 1, and C in this case, because we did add the 10, is positive 10. Okay? And then we're going to divide that by 2 times A, and again, A is 1. Remember, the A, B, and C in here are numbers, not the X's. Okay? All right, so a minus minus 7 is a plus 7, so you got 7 plus or minus, and then 7 squared minus 4 times 1 times 10. You can actually just do that in the calculator. 7 squared minus 4 times 1 times 10 is 9. 2 times 1, 2. And the last I absolutely checked, the square root of 9 is 3. So you have 7 plus or minus 3 divided by 2. Now, a lot of folks get this far and they stop. Well, if there's no square root, there's no radical, there's nothing like that, then keep going. Break this into 2 problems, okay? So you should have 7 plus 3 divided by 2 and 7 minus 3 divided by 2. 7 plus 3, 10 divided by 2, and 10 divided by 2 is 5. 7 minus 3 is 4 divided by 2, and 4 divided by 2 is 2. Okay, so your answer here is x is equal to 5 and 2, or 2 and 5, whatever awesome order you decide to write those in. Okay, but I do see a lot of students, they get to the left-hand side here where it says 7 plus or minus 3 divided by 2, and they stop. You need to keep going. You need to get those singular numerical answers. Okay? Questions on the black problem? Okay. This next one, A is 2, and that doesn't matter. With the quadratic formula, we don't have to divide anything. We can just do it how it stands. Okay, it already equals 0, so we've already met that requirement. So again, you have A, B, and C. So x is equal to the opposite of b, so minus of minus 4, plus or minus the square root. I guess I could move that down a little, couldn't I? There we go. The square root of b squared, again, please use parentheses. So -4 squared minus 4 times 2 times -3. All that divided by 2 times a, and a is 2. Okay. We got a minus 4, which is +4. And then plus or minus, and if you throw all those shenanigans in, 16 minus 4 times 2 times -3, that actually ends up being 40. And then 2 times 2 is 4. Okay. Again, we do have our handy dandy calculator. And you're like, I don't know what the square root of 40 is. Yeah, me neither. I mean, I do, but you know what I'm saying? Square root of 40, put that in your calculator. Boom, there it is. 2 times the square root of 10. So x is equal to 4 plus or minus 2 times the square root of 10 divided by 4. Now, there is something fun about this. I know I just used the word fun and math in the same sentence. You guys are like going to come at me. Okay. Interesting is that 4, 4, and 2. So these guys right here. Okay. You can reduce all of them by 2. The 10, you cannot. You cannot because it's in a radical. Okay. You can reduce all of these by 2. Okay. So 4 divided by 2 is 2. 2 divided by 2 is just 1. So you're just left with the square root of 10. And 4 divided by 2 is 2. Now, you can separate this. You can write this as x is equal to 2 over 2 plus or minus the square root of 10 over 2, which becomes 1 plus or minus the square root of 10 over 2. You do not have to do the simplifying part. This is sufficient. Okay? You can keep it lumped together as one solid answer. Now, the difference between the red answer and the black answer is the red had a square root in it, which we cannot simplify without turning it into a decimal, which is a no-no unless asked to do so. Whereas the black ones had no square root, and so we could easily add and subtract those numbers without having decimals. Okay? Questions, comments, concerns?
I have a question. So what if we divide the 4 on the numerator and the 4 on the denominator? We can't do that, right? Because the answer will be different.
If you do that, you're over here at 1 plus or minus the square root of 10 over 2.
Mm. Ah, okay.
Mm. How did you know to reduce them by 2?
Because they're all even. All even things can be reduced by 2. Okay. What else you got? Okay. The next thing we are doing these in 1.5, these are basically just homework problems. So I'm not going to do a lot of examples. I'm only going to do, there's a section here. I'm just going to do one of these first couple sections just because they're homework problems. And you can always go and get help on those and things like that. So the first set is not anything we ever assess over. And then the second set, sorry, the third set, I suppose, there are three sets. I will do a handful of those just to explain the wording. Okay? All right. But I throw this section in so that you guys do at least get a little bit of help on the homework. But there's nothing in here that we actually assess over. All right. So right here we have the length of a rectangle is 5 more than twice the width. The area is 99 square meters. Find the dimensions. Okay. Well, the area of a rectangle, last I checked, is length times width. You know what? I'll make that a capital L. Okay, because if not, it kind of looks like a 1, which also kind of looks like an I, which also kind of looks like a lowercase l. So we just do capitals. So the area is the length times the width. Okay, so if I have my little rectangle here, ta-da. Okay, the length of the rectangle is 5 meters more than means add, twice the width. So 5 meters more than twice the width. 5 meters more than twice the width. Okay. And the width is just the width. Okay. But we do know that the area is 99 square meters. So that's my A. So you have A is equal to 2W plus 5 times W, because it's length times width, and length is 2W plus 5. And we know that that A is 99. Okay, and you're going to distribute that W, so that becomes 2W squared plus 5W. Okay, can't really solve it this way, so I am going to subtract the 99, and I'm going to use some fancy dancy math that we've been practicing. And in this fun case, this is the fancy dancy math called the quadratic formula that we just did. Okay, so this is one of the instances where we're going to utilize the quadratic formula because there are no factors that multiply to give me negative 198 and add to give and subtract to give me 5. So we can't factor this guy. Okay, so we've got the opposite of B plus or minus. I'm just going to write this because the quadratic formula is written on the other notes. B squared minus 4 times A times C divided by 2 times A. Okay. Opposite of B, whereas in our two previous examples, we had a minus minus. Well, in this case, B is a positive. So it's just the opposite of positive 5 plus or minus the square root. And again, still using parentheses, 5 squared minus 4 times 2 times negative 99, which I'm going to use a calculator for because I don't know that math in my head. And then 2 times 2. Okay. So this simplifies into negative 5 plus or minus the square root of 817. What? Divided by 4. Now, this is one of those times where that handy dandy calculator is going to do you a handy dandy favor. Okay? Because we're going to use our calculator for this. So we're going to break this into 2 problems and we're going to round, right? We're going to round because we don't know what the square root of 817 is. And the last time I measured something, I didn't look at my tape measure and go, wow, that's the square root of 817 feet long. Because you know what? Right? So there we go. So, put up your little fraction bar there. And you're to go -5, and you're only going to do one. You're going to say plus because your calculator can't do plus and minus. Okay? The square root of 817. And then put the 4 on the bottom. Okay? And it's going to pop up like that. And you're like, thank you, stupid calculator. What are you doing? You see the 2 double arrows right above the enter? You're going to click that. And it's 5.8958. Guys, if you round that all the way up, it's 5.9, right? Because everything just keeps pushing everything up. So it's 5.9. So I have 5.9 meters. And then I'm going to do it again. But this time I'm going to do the minus. So I'm going to do my fraction button. -5 minus the square root of 817 divided by 4. And your calculator is going to do that thing again. Thank you for nothing, calculator. You're going to hit your double arrows, and it's -8.4. Which one of these is the length, or the width, I should say? 5.9 or 8.4, because we're solving for our width here, right? Because that's our width, because we're solving for W. So which one of these is our actual width?
The 5.91.
Yeah. Can I have negative lengths? Absolutely not. I can have negative numbers. I can have negative temperatures. I can have a negative account balance, but I can't read a ruler and it tell me a negative number. So the only thing that makes sense is that my width is 5.9 meters and my length is 2 times 5.9 plus 5, and my length is 16.8 meters. So there you go. Like I said, these are on your homework. Okay? You're going to have something like this on your homework. Interesting. Okay. All right. Questions on this one? Okay.
Uh, on the at the beginning of that, A equals 2W plus 5 times width again. Uh why do we multiply that whole equation by with a second? Well, yeah, a second time at the end of it.
Because over here, area is length times width, and down here on the picture of my rectangle, the length is 2W plus 5. So I have to multiply 2W plus 5 times W to get 99. Okay. Let's go down here and talk about our round robin tennis tournament. Okay. In a round robin tennis tournament, each player plays every other player exactly one time. If the number of matches given is by n, capital N, is equal to lowercase n times n minus 1 over 2, where little n is the number of players in the tournament. If 45 matches were played, how many players were in the tournament? So capital N, the number of matches is capital N, and the number of players is little n. Okay? So I have 45 matches, that's capital N. So I have 45 is equal to little n times n minus 1 over 2. Okay? Times it by 2. So you get 90 is equal to little n times n minus 1. You do want to multiply those n's. So you get 90 is equal to n squared minus n. And again, quadratic, right? Because we want to set it up as a quadratic. So I'm going to subtract the 90, n squared minus n minus 90, and then obviously 0 equals that. Okay. There are digits that multiply to give me negative 90 and subtract to give me negative 1. So this is factorable. If you did not know it was factorable, you could use the quadratic formula as well. If you're like, how do you know that factors? Years and years of practice, that's how. But if you don't know if it factors or not, use the quadratic formula. So negative 90, and that's negative 1. What multiplies to give me negative 90 and subtracts to give me 1? 9 minus 10. Okay. So then I have n plus 9, and n minus 10 is equal to 0. N plus 9 is equal to 0. N is equal to negative 9. N minus 10 is equal to 0. And n is equal to 10. What does n stand for, little n?
Number of plays.
Number of players. So which of these answers is accurate?
10.
10. I can't have negative people. You can't have negative people. Boop. So in this case, there are 10 players in the tournament. Right? I can't have negative lengths. I can't have negative people. And I'm not talking about their attitude, guys. I'm talking about actual physical people. Negative people, they're deceased. Right? They don't exist no more. And for the sake of not having to do the zombie apocalypse, I hope 9 zombies aren't playing in a tennis tournament. All right, questions on that one. Again, those first 2 that I did, those were homework problems. You will find those on your homework. Okay. This next set, these are the most common type of quadratic problems because they're always wanting you to find the time. How long did it take for when I shot that cannon off of a cliff? Because we do that all the time, right? I mean, I do that in my spare time. I shoot cannonballs off of the Grand Canyon. Said no one ever. All right. A ball is thrown upward from the top of a 50-meter building with an initial velocity of 20 meters per second. And just so you know, throwing things off tall buildings is actually quite dangerous. If the height is tall enough, it is tall enough, and you drop a very tiny object, you will hurt somebody. You may even unalive them. Okay? The height h in meters of the ball after t seconds is given by, boom, that equation. After how many seconds will the ball hit the ground? Okay, well, after how many seconds will the ball hit the ground? That means we need to solve for t. Okay, and when the ball hits the ground, that means h of t is equal to 0. Okay. So here we go. So we got 0 is equal to negative 5t squared plus 20t plus 50. Okay. Because we are asking for time, very rarely is this ever going to be an even answer. Okay. When they ask for time, you are more than likely going to use the quadratic formula. because that's just the way it is. Again, opposite of b plus or minus b squared minus 4ac divided by 2a. Okay? So in this particular case, I want my time. My time is equal to the opposite of b, so negative of, or the opposite of 20. Plus or minus, using parentheses, 20 squared minus 4 times negative 5 times 50. Divided by 2 times negative 5. And our handy dandy calculator does a lot of this for us. So negative 20 plus or minus the square root of 1,400, which I know that off the top of my head. That was sarcasm. Divided by negative 10. Okay? And just like we did with the other one, we're going to have two answers, and we need to figure out which answer is going to suit us the best. So you grab your handy dandy calculator. It's like your handy dandy notebook if you were into Blue's Clues. And you're going to use your fraction bar there. And you're going to go negative 20. Do the plus one first. The square root of 1,400 divided by negative 10. And again, it's going to get, oh, it didn't that time. Thank you. I thought it was going to give me some shenanigans. So negative 1.7 seconds. Or do your other one. Negative 20 minus the square root of 1,400 divided by negative 10. And that is 5.7. Which one of these answers makes sense?
The 5.7 seconds.
Yeah, guys, I can't have negative time, right? It'd be cool if we did. That means we could go back in time, but we can't go back in time, sadly. So there you go. It's 5.7 seconds. Okay. Questions on that one?
On our tests, will we need to remember, will we need to memorize a quadratic formula, or would have like the formula written down for us?
The quadratic formula will be given to you on the midterm and final exam. Okay. All right. Questions, comments, concerns? All right. That's going to hit the nail on the head for a lot of your homework questions for that section. It's just a lot of application, mostly of the quadratic formula, interestingly enough. Okay. I want to hit some highlights here. And the reason I want to hit these highlights is because you're getting ready to have a quiz over this, right? This is going to be on the quiz on Thursday. Okay, so the quiz on Thursday covers this problem called U substitution. Okay, now solving using U substitution, there are some things that you do. The U is always the B term. Okay, change your polynomial equation to a quadratic formula and to the form of AU squared plus BU plus C is equal to 0. And this will always be the case. It is never not the case. Always, always, always. Factor and solve, use the quadratic formula, complete the square to find the solutions of U. Just so you know, you will be able to factor all of them. Okay? So when we do the U substitution, when you're assessed over the U substitution is on your midterm, U substitution's on your final, U substitution's on the quiz on Thursday. Okay. The reason being is because if Math 136 is not your final stop, you use U substitution in the next set of classes as well. Okay. Back substitute the original value of x in for the u, solve for x. All right, so here's my little helpful hint. So solve for x when you have a rational exponent, you raise both sides of the equation to the reciprocal of the rational exponent. So for an example, x to the 4/3 equals 6 is solved by x to the 4/3 raised to the 3/4 power, and 6 is raised to the 3/4 power, and you get 3.8. Yes, sometimes you end up with decimals. It is what it is. Okay. Let me see. On the problems I'm doing, I'm going to double check here. I'm just verifying to make sure I don't get anything crazy weird. Okay. I mean, I do on one of them, but it's perfectly fine. So we'll be good. Okay. So those are your directions for solving with U substitution. So let's actually do U substitution. Okay. So first things first, the first step says the U is always the B term. Well, B is x squared. So that means U is x squared. Okay. So in this case, U is equal to x squared. Now, by the way, this equation is factorable. I did that so we could get a grasp on things. So it was a little bit easier for before we get into the weird, crazy exponents, but just so you know. Okay. So U is equal to x squared. All right. And then it says, change your polynomial equation to a quadratic equation of the form AU squared plus BU plus C. This will always be the case. All right. So this is U squared minus 5U plus 4 is equal to 0. Okay. I did tell you these were all going to be factorable, and they are. But multiplies to give me 4 and adds to give me -5, -1, and -4, right? So I've got U minus 1, U minus 4 is equal to 0. And then it says solve for U. So U minus 1 is 0. So U is equal to 1. U minus 4 is equal to 0. U is equal to 4. Okay, easy enough. Back substitute the original value of x in for U. What is U originally? U is what? Right here. I'm circling it. Hello? Is this thing on? What is U, guys? What is actually U? U is not U. U is what?
X squared.
X squared. Okay? So back substitute. So boop, we're going to put that back. X squared is actually 1. X squared is actually 4. Okay? And the last step says solve for x. Okay. Well, to solve for x here in this particular case, I'm going to have to take the square root. And the square root of 1 is plus or minus 1. Take the square root again. And x is plus or minus 2. So there you go. Yay. And by the way, I just copied and pasted the whole check box. There's nothing to check here. When we get to ones that you need to check, I'll tell you. Okay. It was just easier to put the whole box the same and make the whole thing look the same. What questions do you have?
Can I get a couple minutes to write this down? I had to print it out.
Sure. Absolutely.
Thank you.
You are welcome. All right. So normally our U substitution problems don't look like this, right? And you're like, oh, of course they don't. You're right. Of course they don't. They look like this. Okay. So it's the same thing though. U is always the middle. So in this case, U is equal to X to the 1/3. Okay. And we don't need that checkbox, by the way. Okay. U is equal to X to the 1/3. So this becomes U squared minus 5U plus 6 is equal to 0. Okay. And you're like, all right, well, what multiplies to give me 6 adds to give me -5, -2, and -3, right? -2 times -3 is +6. -2 plus -3 is -5. So you're left with U minus 2 and U minus 3 is equal to 0. Solve for U. U minus 2 is equal to 0. U minus 3 is equal to 0. Going to add the 2. U is 2. I is not. I is 44. And right here, add 3. U is 3. Come on, guys. Giggle a little. Actually, I had to stop and think for a second after I said that. I couldn't even remember if I was 44. All right. So guys, right here, back substitute. U isn't U. U is X to the 1/3, right? So boom, change that back. X to the 1/3 is actually equal to 2. And boom, change that back. X to the 1/3 is equal to 3. Okay. Now I'm going to scroll up to my little helpful hint here. So it says, helpful hint, to solve for x when you have a rational exponent, you raise both sides of the equation to the reciprocal of the rational exponent. Okay? So if my rational exponent is 1/3 or 1/3, what's the reciprocal of 1/3?
3.
Yeah, 3 over 1 or just 3. So I'm going to raise that to 3 and that to 3 and this to 3 and this to 3. Now, the cool thing about this is leaving your answer with exponents is perfectly acceptable. So you get x is equal to 2 to the third power, or if you feel like multiplying it, it's 8. And this is x is equal to 3 to the third power. And if you feel like multiplying it, it's 27. Okay. So with the exponent answers, you don't actually have to multiply them. You can just leave it as 2 to the third or 3 to the third. Okay. So you can just leave the exponents. You're like, I don't want to do the extra step. Okay, that's fine. It's correct either which way. Is there a third one? This one. Okay. Try the third one, please. Try that one, please. I have no idea. I didn't actually multiply them out. Give me 1 second. Uh, do, 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 do. Um, the first one is correct, but the second one is not. You might have typed the wrong thing in your calculator. So just double check the math there.
I'm confused about that part, the negative one.
Before you raise it to the exponent, type in what you got. Leah, you are close. There should be a denominator on those exponents. Okay, yeah, Upasana, that's right. I'll cover how to put it in the calculator when we're actually discussing it. Would anyone like more time?
Just 1 more minute, please.
Yeah, no worries.
Thank you.
No, Cesar. I I can see what you did, but you still need to finish it up a little bit. Yes, Leah. Serenity, you're missing a sign on the first one. But yes, that is correct. All right, time check again. Anybody need more time or want more time, I should say? Okay. In this case, guys, u is equal to x to the 3 over 7. X to the 3/7. So you get u squared plus 2u minus 24 is equal to 0. And what multiplies to give me negative 24 subtracts to give me 2. 6 minus 4. So you got u, u plus 6 and u minus 4 is equal to 0. U plus 6 is equal to 0. U is equal to negative 6. U minus 4 is equal to 0. U is equal to 4. But remember, u isn't u. U is x to the 3/7. So this is x to the 3/7 is equal to negative 6. And this is x to the 3/7 is equal to 4. Now, this is one of those where I encourage you to not multiply it out because you're going to end up with some weird, crazy decimal. But if you would like to, again, it is not illegal. So the reciprocal, we're going to raise these to the 7 over 3 power because that's the reciprocal of 3 over 7. 7 over 3, 7 over 3. So I get x is equal to negative 6 to the 7 over 3. Please try to put that in parentheses. And same with the 4. X is equal to 4 to the 7 over 3. Okay? If you do want to put those in your calculator, you're going to go over here to your calculator. You're going to use the parentheses. So let's go with negative 6. And then this little button, it's attached to the 7. It's catty corner. It's diagonal. And it's the little caret. And it's going to give you an exponent. And you're going to go 7. And then your fraction button, 7 over 3. And it's negative 65.4. Okay, and then same for the 4, parentheses 4. Hit that little button, it's called a caret. And then 7 over 3, and boom, 25.4. Ish, give or take, right? If we're rounding. That's why when you have to round, that's why I don't recommend it. That's why I'm like, just keep them like this in their lovely fractional state.
I did the same thing that you did on the same calculator, but it's giving syntax error.
You got to put this negative 6 in parentheses.
Yeah, I did that.
Are you using the calculator that I'm using, or are you using one of the blue ones with an ABC button? Do you have an ABC button on there?
Um,
'Cause
no,
then I don't know. I mean, without me being there to help you or physically see it, I can't determine the error. I know calculators, so, but
is it okay if I leave the answer like the
I would
one?
like you to leave the answer like
Okay.
this, like I have it boxed up. That way
Okay.
you don't have to worry about decimals. And then you don't have to worry about calculators going, no, you're wrong. And you're like, no, I'm not. Okay. Sorry, I want to look at something real quick. One second. I got to stop sharing. Sharon! You guys probably have no idea who that was. beep, bop, boop, ba, da, ba, 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 ba. Okay. All right. That one. I'm going to do that one. I wanted to know where I should go next. Because there's stuff I want to show you, but there's obviously stuff that's a bit more of a priority than others. Okay. So we are going to solve square root equations, but we're going to skip the first couple because there's ones I want to show you instead. So you're going to isolate your square root expression, square both sides. Squaring the square root eliminates the square root. Expressions under a square root would just come out of the square root without any changes. Constants get squared. Binomial factors will get FOILed. You solve for x and then check for extraneous solutions. So these fun little boxes that we've had this whole time that say check, 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 right? That just, that's for these. Nope, I don't want to do that one. I want to do this one. Okay? We're gonna do this one. All right, so when you square a square root, right? So to solve these equations, you're going to square both sides. Okay? A square cancels out a square root, so you're left with x plus 4 is equal to x plus 2 squared. Well, that x plus 2 squared, I need to FOIL. So you've got to write it off to the side and FOIL it. X times x. So hold on, I'm going to write it over here. We've got x squared, and then 2x plus 2x, that's 4x. And then 2 times 2 is 4, right? So you got x squared plus 2x plus 2x plus 4. Okay? Then, because this is what we do, you've got to get all the x's and all the stuff together, and you got to get this equal to 0. So I'm going to subtract x, and I'm going to subtract 4. Okay? So 0 is equal to x squared. 4x minus 1x is 3x. And 4 minus 4 is 0. So it just sort of stops there. You're like, cool, cool, cool. That's great. That's great. Love it. Okay. Why did I skip one? Oh, that's why. Never mind. So when I did this problem originally, I was like, where did that problem go? When I did this problem originally, apparently it came out to be a quadratic answer, which is not very fun to do. So I forgot I changed the problem to where it worked. All right, so there we go. You are going to have to factor this by the greatest common factor. And x squared and 3x share an x. So you have x and then x plus 3. You set the greatest common factor equal to 0, so x is equal to 0. You set the parentheses equal to 0 and solve. So x is equal to negative 3. Okay. Your job now is we have to check these answers. Does this work? So you've got the square root of 0 plus 4 is equal to 0 plus 2. 0 plus 4 is 4, and 0 plus 2 is 2, and the square root of 4 is 2. When you're checking, by the way, you only concern yourself with the principal root, which is the one that the calculator spits out. Okay? So 0 does work. Hooray! do the same thing with the -3. Okay, we got the square root of -3 plus 4 equals -3 plus 2. -3 plus 4 is 1. -3 plus 2 is -1. The square root of 1 is 1. 1 does not equal -1, so -3 is what they call extraneous. So it is not an answer. So the only answer is 0. Yes, that does happen, and it will happen. Okay. Sorry, I'm looking to see how they came out. All right. So let's do this one. Same thing. Square both sides. So you get 4x plus 1 is equal to x plus 1 squared, and I have to FOIL that. So x plus 1 and x plus 1, boop, x squared plus x plus 1. So 4x plus 1 is equal to x squared plus 2x plus 1. Again, get the x's and the 1 over there. So 0 is equal to x squared minus 2x. And that's it. That's it, right? So it's like, whoop. Again, we are going to factor by the greatest common factor. So the greatest common factor is x. And then x is equal to 0. X minus 2 is equal to 0. And x is equal to 2. Make sure you check your problems. Just like in real life, things get messy when you start messing with x's. Okay? So when you're squaring the x's, it gets messy in math. That was the joke of the day, by the way. All right. So plug in the 0 just because 0 is easier. And then equals 0 plus 1. 4 times 0 is 0. So you have the square root of 1. 0 plus 1 is 1. 1 equals 1. Yay! So 0 is an answer. Now you plug in the 2. 4 times 2 plus 1 is equal to 2 plus 1. 4 times 2 is 8. 8 plus 1 is 9. Square root of 9 is equal to 2 plus 1, which is 3. And the square root of 9 is 3. Yay! So in this case, both answers, both are solutions. Okay? I feel like... Oh, that was the one. Okay. Questions, comments, concerns?
On tests, if we solve these questions using slightly different methods, will it mess with our credit for it?
I mean, does it make mathematical sense? That's what
Yeah,
I'm looking
let's
for.
assume it makes perfect mathematical sense. It's just not the same method that,
And that's
like,
what I'm looking for. I'm looking for it to make mathematical sense. That is what I need.
so like if we got a question we didn't use substitution or something like that, it would be fine.
You are not going to be able to solve the problems that are on the quiz, final exam, and midterm without using U substitution.
Ah, okay.
Okay? And the last item I want to hit before we go is absolute value equations. You're going to isolate the absolute value expression if you need to. The absolute value expression looks like the giant sticks. Okay? Create two separate equations. One equation will be the original equation without the absolute value symbols. One equation will be the original absolute value equation without the absolute value symbols, and then the opposite of everything on the other side. Solve for x, check for extraneous solutions. Okay? We are going to solve this problem right here, but I'm going to make some alterations. So we're just going to absolute value of x plus 2 is equal to the absolute value of, sorry, I lost what it was. 2x plus 4. Okay? Okay, that's what I want you to change it to. All right? So when you have two absolute values, technically you have four equations, but those four equations all turn out the same two answers. So you don't need four equations, you just need two. Okay? Because in all technicality, don't write this down, this should be x plus 2 equals 2x plus 4. X plus 2 equals negative 2x minus 4. Again, do not write this down. Then conversely, you have, you end up repeating it because the original absolute value, so you end up with x plus 2 equals 2x plus 4, and then you end up with negative x minus 2 equals 2x plus 4. There's no need for all that shenanigans, okay? That's why I said don't write it down. Okay? So your job is to just pick one of the absolute values to keep the same, and one of the absolute values, stop running away from me. Like it's like running away. Pick one of the absolute values to stay the same, and one of the absolute values to make the opposite. How I do that is I keep the left the same. All right, so keep this in the same. Okay, and this one we're going to change. So now you can write these down. So you should end up with x plus 2 is equal to 2x plus 4. And then I'm going to keep that the same. X plus 2 equals negative 2x minus 4. Okay? And then we're going to solve for x. Told you it was running away from me. I don't know why it was. Stop it. Ha, sucker, I got you. Okay? All right, so I'm going to subtract x. 2 is equal to x plus 4. Then I subtract 4. Negative 2 is equal to x. Trying to keep my variable positive, I'm going to add 2x. So I have 3x plus 2 is equal to negative 4. Subtract 2, 3x is equal to negative 6. Divide by 3, x is equal to negative 2. Well, that's weird. You know what? I don't need it to make sense. I made the problem up out of the top of my head. All right. Oh, I know why. It's because I doubled it. Poopy. That should have been a 6. Oh, well. We can change that to a 6 real quick. That way it's not the same answer. It's still negative 2. How did that happen? Oh, that should be an 8. I was like, wait, what did I mess up? Subtract 2, that's 8, 8, and then that's 8 over 3. Okay. So now you have to check them. Absolute value means everything's positive, so negative 2 plus 2, so that should be 0, is equal to 2 times negative 2. Oh, shoot. We got to keep it as 6. Sorry, kids. Because that would require me to change the whole other problem. But the good news is we only have to check it once. There we go, plus 4. So 0, the absolute value of 0 is equal to the absolute value of 0. So 0 does equal 0. So -2 is my answer. Both -2s, technically. Sorry, I know that was a lot of erasing. You guys are like, why am I erasing? But there you go. We will finish this up, but I just wanted to hit some high points to hopefully help you with your homework. All right. Questions, comments, concerns? This is why I don't make problems up. I end up with the same answers apparently. Teehee. You guys are free to go. You
Just to
started to
make sure
say
I
something.
oh, just to make sure I understand. Wait, so how exactly did the absolute value bars like change how we solve it, or did it really? Well, yeah, how did that?
Oh, because I was in a hurry and I just keep hitting the wrong things. What do you mean? How did they help you solve it?
No, how did they change how we solve it? Like, what did they affect in our?
Because you get 1 is positive, like I got 2x plus 4, and over here on the right, I got -2x minus 4. If I could fix my jankety problem.
Can I ask something? So for the x plus 2, why doesn't the sign change for that one?
Because I went through and said that you're going to end up with 4 of the same equation.
Oh, okay.